Hey people of physics, Mr. K here. I want to give you a quick look at investigation 5B. We're going to dig in a little bit to friction forces and think about how those work using everybody's favorite tracks and cars. Here we go. Alright, so this is our pretty standard setup. We've got our track, we've got a launch rubber band, and for part one we just have a single photo gate. Now you're used to using these cars with wheels that roll on the tracks, but this time to think about friction, look at this. We've got a car without any wheels, and we're going to call this a sled. So in the first part, the idea is this. We take the car and we pull it back against the rubber band, pardon me, the sled, and we launch it. And after some practice, you guys know launching cars is hard. Turns out launching sleds is even harder. After some practice, what you'll discover is the sled goes down the track and stops. We're going to pay attention to how far down the track the sled goes and use that to determine the energy loss. So that's part one. And then in part two, same idea, but now we have again the car. And this time you'll notice I've got two photo gates on the track instead of one. And as you can imagine, the car's not going to stop. We're going to launch the car just like we have before. And now we're going to pay attention to the speed at the first gate and the speed at the second gate. And as you might anticipate, it's probably going to change. So we're going to look at how much the speed changes from gate A to gate B, and the time it takes to get from gate A to gate B, and use that to find the acceleration, or if you'd rather call it deceleration, that works. Again, those two parts, first the sled, second the car, and bottom line, our goal is to figure out how much friction force acts between the track and the sled, and between the track and the car. All right, jump on into part one and let's take some data.